My name is Artem. I am presented our work. Monitoring state of Marine plane bearings based on exponential degradation model. Marine plane bearings are used of marine low and medium speed diesel engines, turbines and shaft lines. Monitoring the technical condition and diagnostic emerging defect is the basis of the assuring high reliability of equipment elements. Method of the vibration signal processing in the frequency and time frequency domain are used to assess the technical condition of sliding bearing. Organization of monitoring observation of the operation equipment condition is a main of the increasing its reliability and fail safety. Ship sliding bearings of TRL-88 brand were used as material for analyzing vibrodiagnostic signals. In this work, method of analyzing vibrodiagnostic signals used the exponential degradation models were applied to monitor the condition of marine plane bearing. The use of the model allows to observe the degradation trend in the real time by collection data. This post-processing ranking and marrying of importance function with selection of prediction curves. Maintenance based of interactive conditional monitoring, fault detection and resource forecasting of power equipment requires a whole set of information characteristics, amplitude, time, frequency achieved in this implementation. The method of the principal components allow to reduce the demonstrably without significant loss of input information. The calculation of the principal components and reduce of the calculation of eigenvectors and eigenvalues of the covariance matrix. In the matrix on the diagnostic there will be dispersion of futures and in the other cells covariance of pairs of the future. Degradation models extrapolate past behavior to predict future behavior. This type of calculation is appropriate when determining the steady-state useful life of complex equipment. The degradation profile of the test components is used to statistically calculate the remaining time until the diagnostic indication reach a certain degradation level agreed with the regulation. Statistical characteristics of vibration signals in the time and frequency domain were determined during post-processing. In the time domain, 11 statistic characteristics were determined: mean, STD, skewness, kurtosis, peak-to-peak, RMS, cross factor, shape factor, impulse factor, magnetic factor, energy. In this frequency domain, 4 statistical characteristics were determined: spectral mean, SK mean, spectral standing deviation, SK-STD, spectral asymmetry, SK-S skewness, and spectral excess, SK kurtosis. All the above statistic characteristics of the vibration signals can serve as potential indication of bearing conditional degradation. The main criteria of belonging of the extracted statistical characteristics of vibration signals in the frequency and time domain to the further analysis is the numerical volume or monotonicity. For quantitative estimation of belonging of the statistical characteristic to the future analysis is proposed to use formula characteristical with a monotonicity valence more than 0.3 are selection for the combination in the subsequent analysis used the method of principal components. In order to reduce the dimensionality of the analysis quantities and combine the future of vibration signals, the PESIA principal component analysis method was applied in this work. Using the computer mathematical system MATLAB, the first PCI principal component was calculation when processing the statistical characteristic of vibration signals with monitoring created that 0.3. Its distribution as a function of the day of measurement, which correlated with the successive approach of the state of the plane bearing to failure. The first principal component increases is the bearing approaches failure. Trust. The first principal component is a promising combined indicator of bearing conditional data collection in the first 20 days, 40% of the life cycle, are considered as the training data. Use the exponential diagnostic model algorithm implemented in the MATLAB computer mathematical system to model the exponential degradation processing and estimate the remaining useful life (RUL) of bearing. The degradation models estimate RUL by prediction where the monitored signals crossed a predetermined threshold values. The selection of the conditional indication threshold values may be based on chronologic records of bearing conditional or some subject matter knowledge. Since there is no chronological data in the investigate set, the last values of the serviceability indication HT is selection is the threshold value. The selection of the threshold value is based on smoothed chronological data. The exponential degradation models also provides functionality to assess the significance of the slope. As soon as a significant slope of the performance indication is detected, the model will forget the previous observation and restart the estimation based on the initial a priority values. The confidence interval boundary shown by the dotted line in the figure crosses the threshold already on the 40th day of the beginning operation. Therefore, it can be stated that after 40 days of operation. Further operation of the bearing is unsafe. In order to improve the accuracy of forecasting, it is necessary to constantly replenish the current information at each step of ROL forecasting, statement by the corresponding probabilities. The development of the prediction models of the technical state changed by vibration parameters is a major step of transformation to the quality and new form of maintenance and repair necessary to ensure equipment safety. Thank you for your attention.